Hello everyone. Today I'm going to show you how to visualize results in Abacus program. So you need to go to results and then click on output databases and go to the file that contains the result and make sure you select the ODB, which is the output file, and open the needed file. As you can see, this is the model after solution. And you can go here to the annotation options. I prefer to set all of them off to better view the model. And you can change the background also by going to graphics options. I prefer solid and a white background for screenshots, and then click OK. You can change the view from here. And you can rotate the model as you wish. From here, you can see the deformed shape with colors. And from here, you can change the contour plot options. You can change the colors and a lot of options. You can play around with them. Okay. This is an undeformed shape before applying the rolling condition and force. And this is the deformed shape. And you can see the difference. And you can visualize the full movement of the model from here, and you can change the steps. As you can see, this is the interaction between the road and the tire. This is the movement from another side. You can change it to pressure or any parameter that you need to visualize. You can go here to change the element that you need to view. Choose the element sets, and for example, view the apply doesn't show because you need to change it to deformation. So this is the deformation applies. You can play around with these options, and you can change the contour type to banded, not as of banded, to banded, yes, to visualize the results, and change U3, which is the strain in the Z direction, to show the maximum strain in the contact patch. Also, you can view the annotation to represent the maximum strain value. Just go to annotation option, and that's it. I will just set all off again because I don't like them. It's confusing sometimes. Okay. From here you can change the element type that represented. I will choose the elements in the contact region by long press and draw a box on the desired element and click on replace. So everything will disappear and only the selected elements will be presented to better visualizing the desired area. And same as before, you can play around with other options such as playing the motion as a clip. As you can see, this is the deformation steps. You can change the animation option to slow frame rate. That gave us a better understanding of the distribution center of the strain. So this is the U3, as I said before, which is the strain in the Z direction. Also, we can change the parameter to stress, to view stress at the same region represented here. So we need to choose S and then not mices, let's say maximum, max principle. And same as before, you can play it as a clip to view the stress propagation and distribution during the tire dynamic movement. Okay, and we can show the maximum stress value by showing the legend. Click on apply. Okay, and we can play the video again. And we can save the video as well, the movement video, and from here we can see the inside inner liner of the tire, how the stress distributed inside the tire. Okay, if we go here, we can change the element, go to element sets and choose, for example, the thread and click on replace. This will show the thread elements, and this is the maximum stresses on the thread elements of the tire. You can see the maximum stresses occurs on the sides of the thread elements. You can choose pressure. Another important thing is plotting these data. So we have to go to XY data and right click, then choose create and choose the source, and then choose the variable that you need to plot. Let's say we need to plot the force and displacement, for example. So we will choose, oh, this is the step, okay, for the variables. Yeah, this is the TF3, total force 3 at the Z direction, and then we have to select the displacement U3. Yeah, this is spatial displacement U3. Okay, and then click on plot. We need to click on the Control key and select both variables. As you can see here, the displacement and the displacement in red, and the blue line is for force, which was 3,300 kilonewton. And you can play around with axis options, change the length, the title. Let's say we need to add millimeters for the displacement, and you can see here the title, axis title has been changed. And force, we can add a Newton. We can change the axis options. By the way, the forces and displacement has been run versus time in second. We can just draw displacement vs force. It's up to you which data you need to present. Okay, now I will open another output database, which is for half tire, and I will select U3 as before, and you can go to instances and remove the road. Okay, it does not remove for some reason, I don't know why, but if you click on remove the road service, it will remove the road from visualization to better see the contact region. Anyway, we can make a path to view data for specific nodes or elements. We will choose some nodes at the middle of the contact region. So let's close this one and go to path, create. Let's write strain as center at the contact region, and the type is node list. Click on continue and then add before and select the nodes, which is exactly at the center of the contact region, to calculate the strain at these nodes, and then click OK, done, and then OK. Now we can go to XY data and create a new set, and as a source we can choose a path that we just created, and true distance, and then click on plot. This will show us the exact maximum displacement at the center of the contact region. We can name this data set as displacement at the center of the contact region. Okay. Okay, so this XY data has been saved. We can delete this one. It's just a temporary set. Okay. And let's go to path, and we can make another path. We can either copy the same path, or we can just choose another path. So let's name it at stress at the center of the contact region, and type is node list as well. I have to select the group first, okay, and then select the nodes. I think that's enough. Okay, click on done and okay. So we have another path, and we can repeat the same process. Go to XY data, create path, choose the stress path, and the value X value is true distance, and the field output we have to change it to stress. So this is the stress, stress, and then we have to choose the maximum, okay, and then plot. So this is the stresses are the selected nodes, okay, and we can change this data set, change the name of this data set to be stress at center of contact region. Okay, the last important step is to export these XY dataset out of Abacus. So just right click on the dataset and then click edit. It will show the XY data column. You can just select them and right click and then copy and paste them on the desired software. For example, Excel, to represent the data in figures later or in tables. And by the way, you can change the data. For example, we can change x's data. For example, we can choose another of distance. We can choose time, so it will show us the stress, the displacement versus time. And these are the data set. We can just select and copy them and paste in other programs. You can see here, this is where's the maximum? Yeah, this is the maximum, 16.377 millimeter. This is the maximum displacement here at the selected nodes. And the path is important because if we have a specific region or area, we need to find the exact variables or parameters there. We can make a path and select the data. Okay, this is everything for today. Thank you for your time. And you have any questions, please don't hesitate to write it in the comment below this video. Thank you and goodbye.